All right, so here's the assignment 9.6 part 2 where we have to factor out a GCF first. So I'm going to jump right into this. Hopefully you're using this to check your answers and the process as well. So I need to find a GCF first. Make sure you're referencing your notes here. So step 1 is factor out GCF. We're starting there. All right, so let's go ahead and get back to it. So here I'm going to list my terms, 2x squared, 6x, 4. We need to find our GCF. This will be 2 x's. 6 is 2 times 3. So 2. And 1x, and then 4 is 2 times 2. So our common term in all three is going to be a 2. And that's it. So now I have to put in my middle part, where that's going to be an x squared plus 3x plus 2. All right. Now that I have my GCF taken out, I can do my factoring of this middle part. Let me make this 3 a little bit neater. 3. Okay, so now I'm just going to focus on this middle part, this x squared plus 3x plus 2. So I am going to double parenthesis that. Then I'm going to put an x and an x. 2 is just 2 and 1, so I got my 2 and my 1 there. So 2 and 1, that equals 3 when they're both positive. And then I bring my 2 down, and that would be my final answer there. Okay, so number 2 is similar, where, again, once we factor out our GCF, we're going to have a 1 for our a, so we just go right to the double parentheses. So I'm going to list my factors here. So I have 2x to the third, 6x squared, and 20x. 0. This pen is a little finicky today. So I have 2 and then 3 x's. I have a 2 and a 3 and 2 x's. And then 20. We have a 2 and a 10, 2 and a 5. So it's 2 2's and a 5. And then 1x. So I look at what's in common in all three. I have a 2. So I bring down the 2. Then I have an x. Bring down the x, and that's it. That's the only thing that's in common in both of them. So I have my 2x as my greatest common factor, and on the inside we have an x squared, so that's what's left over, 3 and an x, so plus 3x, and a 2 and a 5, which would be multiplies to equal 10. Now again that my GCF is taken out, I can now factor this inside part. So double parenthesis, x and x. So I have negative 10 that adds to equal 3. Well, 10 is just 1 and 10 and 2 and 5. Oops, 1 and 10 and 2 and 5. I was thinking ahead of that too. And if it's negative, we have to have 1 of each. So I'm going to focus on that 2 and a 5 because there's a difference of 3 there. And to make that a positive 3, this would have to be a positive 5 and a negative 2. Because when I add those together, that equals positive 3. So I have my minus 2 plus 5 and bring down my 2x. And that is my final answer for that one. Okay, so now these next two are a little bit more involved because we're going to have to do the a times c when we do it. So when I'm here, I'm going to take out my GCF, 6x squared, 26x, 24. Again, the same first step, 2, 3x, x. 26, take out our calculator, 26 divided by 2. 2 and 13, so 2, 13, and an x. 13 is prime number, so I can't break that down. 24 breaks down to 2 and 12, 2 and 6, 2 and 3. So 1, 2, 3, 2's and a 3. All right, now what's in common in all three? Well, we have a 2 here, 2 here, 2 here. So I'll bring that 2 down, and then that looks like it, right? We have a 3, a 13, a couple 2's, 3's, x's, but that's about it. So what I will do is now rewrite this problem as a 2 on the outside, and then on the inside, we have a 3x squared, 13x, and we have 2 times 2, which is 4, and then times 3, which is going to be our 12. So then a plus 12. Okay, so now we have to do our a times c here, because in here we have a 3 for our a. So I do 3 times 12. So I'm just factoring this middle part now. It's like a whole new problem. 3 times 12. It gives me 36. So I'm going to rewrite this as x squared plus 13x plus 36. Now I'm going to factor the 36. What multiplies to equal 36, that adds to equal 13. We know it's not going to be 1 and 36. So let's keep going from there. 36 divided by 2. 2 and 18. All right, that's not going to equal 13. Let's do 36 divided by 3. Oh, we need it to equal 13, sorry. So we have 3 and 12. All right, 3 and 12, no combination of 3 and 12 will equal 13 that I can tell. So that was 3. Let's try 36 divided by 4. So we have 4 and 9. 9 and 4. Oh, look at that. 9, 10, 11, 12, 13. That's 13, right? So let's use the 9 and the 4. So plus 4 plus 9. And I'm using both positives because this middle term is positive. Now we divide by our original a. So we divide this by, and our original a is this 3. All right, now we reduce the fractions. So let's check to see if these fractions reduce here. So take out your trusty Desmos calculator, and we would do 4 over 3. You can see that that's already reduced. And then the 9 over 3, you should know what that is. Whoops. So 9 over 3. And that reduces to 3. So I rewrite this as x plus 3. And since this is reduced, the 3 now goes with the x. 3x plus 4. So there's my factored part. Then I bring this 2 down and put it on the outside. And that's the final answer. So that is factored completely. All right, the last one we have here. So we need to factor out the GCF again. So 25x squared, 10x, 15. All right, I'm going to do these in my head because 25 is just 5 times 5, and then 2 x's. 10 is 2 times 5, and an x. 15 is 3 times 5. All right, so what's in common in all three? Hopefully you recognize that. You can see that there is a 5. And that is all that's in common. So the 5 comes out. And then inside the parentheses, we put what's left over. So 5x and x will be 5x squared minus, minus 2x minus 3. And that's what's left over. All right, now I'm back to factoring this inside part. Slide and divide method. 5 times 3 gives me 15. So x squared minus 2x minus 15. That's step 1. Then we have to factor this, double parentheses. We can do that now because the a is 1. So what are our factors of 15 that combine to equal 2? Well, we only have 1 and 15 and 3 and 5. Those are only 2, right? So we're going to have to use a combination of 3 and 5. Remember, when we're dealing with a negative number, one has to be negative and one has to be positive. So when you add these together, the combination that comes out to negative 2 is positive 3 and negative 5. Now we have to divide by our original a, which in this case will be that 5. and then we reduce the fractions. So 3 over 5 remains 3/5, and 5 over 5, we should know what that is. 5 over 5 reduces to 1. So I rewrite these problems as x minus 1, and then this one is going to be the 5 with the x, 5x plus 3, and bring down this original GCF on the outside of the problem. Again, these last two are much more involved, so they're a good challenge. If you have a good grasp on how to do it, then challenge yourself. If not, make sure you are capable with doing problems 1 and 2 where we take out the GCF and then just factor the middle part.